Okay, welcome to the Free Teach channel. Today we're going to be doing a bit of an intro to trig. We're going to be looking at reference angles, sides of the triangle, and trigonometry ratios. Okay, so this is all the pre-stuff that we need before we can get stuck into solving trigonometry problems. Okay, again, stepping right out of Pythag for some of us, and we are again looking at right angle triangles. So our trig is going to be based around right angle triangles. We're not going to go any deeper than that. And to start with, we're going to talk about reference angles. A reference angle is an angle, is just knowing which angle we're talking about. Okay, so you can see here in a triangle, we've got the right angle here, and we've got an angle here. I'm going to put a symbol there. Okay. And we've got another one here. Let's pop alpha there. Okay, so we call this theta, okay, and the other one alpha. So that one is called theta, and that one looks like a fish is called alpha. Now, I could say that I want to use the reference angle theta, and it means that we're talking about the angle from here. I'm going to focus on that one for now. Okay, so I'm going to take out that one. Right, so using theta as a reference angle, we can now show or name our sides of our triangle. Now, similar to those with experience in Pythag, we know that the side opposite the right angle is our hypotenuse, right? So label that H. And the other two sides that we have in trigonometry are our opposite sides and our adjacent sides. Okay, so the opposite side, so H stands for hypotenuse. O for opposite. Oops, messed up my P there. And A for adjacent. Okay. Now, the way that we tell which is which is we can we tell which is which by looking at our reference angle. Okay, so from the reference angle, hopefully we know that if something's opposite us, it's across from us. So opposite our reference angle is that side there, the side with the 3 on it. So we'd label that as O. Okay. Now adjacent, we'll pop that next to it, is easiest to be remembered if we think of it about it in terms of it's next to something. So if you're adjacent to something, you are next to something. All right? And next to theta at the moment, you'll see we've got both H, or our hypotenuse, and the side that's 4, okay, are both adjacent to theta. The good thing is, or the clarifying thing is that if we've already named the hypotenuse, we cannot also give it the adjacent term. So, because of that, this side here is our adjacent side to theta. Okay. So that's how we label hypotenuse, opposite, and adjacent. The hypotenuse is always the longest side. Okay. Opposite is across from, and adjacent is next to our reference angle, all stemming from that point. Okay. Now, going back to alpha quickly, if we get rid of those for a second. If we were to change our reference angle, so if we said, okay, let's put alpha back here, and I said, okay, what according to alpha, what's our opposite and our adjacent angles? They would change. Hypotenuse is always along the side, so that doesn't change. But from here, from alpha, the opposite is this side here, and the adjacent next to it is our 3. Okay, so that's why it's important to have something that you use as the reference angle, because these can change depending on which reference angle you're using. Okay. Now on to trig ratios. So trig ratios, we use opposite, adjacent, hypotenuse to make our trig ratios. Our trig functions are sine, cosine or cos on your calculator, and tan. Okay. And with that, I'm going to use theta, so I'm going to get rid of that there and change these around to the right way. So from theta, this is our opposite side, and this is our adjacent side. Okay. Now from theta, our sine ratio is that the sine of theta, so that angle, we always have the angle there, and we don't know the value, so we're just going to say that it's theta. So sine of the angle is equal to opposite over hypotenuse. Okay. Next up, cosine, we're using theta again. Cosine of theta is adjacent over hypotenuse. And lastly, the tangent of theta is equal to the opposite over, sorry, I nearly wrote there, hypotenuse there, I want, over the adjacent sides. Okay, so these two are equal to sine of the angle, which is theta at the moment. This will, when we get into it, have a value. And by using that, we can come up with a little mnemonic, a little rhyme that tells us how to remember what goes with what. And that's a bit thick. And what we do is, it's called sa ka ka tawa. Okay, so you can see that sine work, sine opposite over hypotenuse, so sine opposite hypotenuse. Okay, so you've got the function and in your fraction, the top number or the numerator, and your bottom number or the denominator. So if you were asked to write out what the trig ratio is for this triangle for sine, we would say that the sine of theta is equal to the opposite over the hypotenuse, O over H, which for us here, we've got numbers that we can replace there. So opposite is 3 over 5. Okay. The cosine of theta is equal to A over H, which is 4 over 5. So our value of A over our value of H. And if we want to finish it off, tangent of theta is equal to O over A. Just going to pop them straight in. So 3 over 4. Well, hope that helps you with your intro to trig. Like, subscribe to the channel, etc. And we'll see you next time. Thank you.